Okay, let's get started. Mondays, after the review of the exam, several people come to me and said that they also want to know how to do that 50 points extra credit problems. And, well, here's my deal. I don't want to show you exactly how to do it, but we'll double check. You can stop me anytime you want, but I prefer, just show you the thinking process, and if you can see it, then we know you can do it. Okay. Not this one. Okay. So the problems of the extension is the blocking, right? So let me put it this way, okay? Originally, we said that there are 256 possibility run, right? And then so there are 256 possibility. And then, let's use a lighter color. And then we said that let me find 3 confounding factor, okay? And use those 3 confounding to, 2 by 2 by 2, so break them into 8. So 256 becomes a possibility of 32 runs. So far, so good? Yeah? We are on the same page there, right? Now, here comes the tricky part is, now I said that, by the way, for those 32 run, whichever one of the 8 you pick, okay? Then I suddenly said that, I don't have enough money to do that 32 in one shot. I have to turn this 32 into 4 blocks. Okay, so I need to turn this into 4 colors. That is the problem, right? So everybody agree that that's the problem? We need to turn them into 4 blocks. Okay, when you do this, okay, obviously there will be blocking effect take out of the sum of square. Okay, and there are sum of square from the what we have, the B effect, C effect, or B effect, C effect, AC effect. Those are the main things we want, right? And so if you have the pie chart of the sum of square for B, C, A, E stuff, and the rest will be downstairs in the F-test, okay? When you partition the total sum of square, well, let me put it this way. The total sum of square is whatever the value you have, 32 of them, the total variation, right? And you just break them into 2 pieces, right? Things you care, things you don't care. So when you try to get your sum of square for your blocking, okay, what will be the big no-no? What will be the things that you said, man, if you do that, legally people will say cheater. And the other thing is that that the investigation will be corrupted. What will be the case? Anybody? Here. Let me show you how to make this terrible. Okay, so how to set up the sum of square. I know that at the end, well, let me just put it this way. We have sum of square from the model. Okay, and the model actually including sum of square B term and sum of square C term and again. The sum of square C par and the sum of square what we have, the AC par, right? The interactions. And then we said that because we want to talk about AC, we have to have the A term in, right? So we have the sum of square A. But that one is, it's not going to be significant, but we just have to leave it in. Okay? So everybody agree that 32 degrees of freedom of sum of square will be, break them into this piece and this piece, right? What will be bad is if I have my blocking effect, so now I have to add a term called sum of square blocking, okay? Based on 4 blocks, okay? What will be terrible? Come on, young lady, is anybody, help me. What will be terrible?
If your blocking effect is confounded with B, C, AC, or A.
Yeah, so if you do that, then people will say that, well, where did you get your A effect? Is it you get it from your blocking, or you get it from the real A effect, right? So let me do the totally wrong things first, but because the wrong thing is one of the possibility. So let me put it this way, okay? If, okay, how I'm generating my block. So I will have a block generator. I'll just call it BOK. And then the BOK, let me say that I want to have the B effect. So if, okay, B is equal to 1, I'll call it 1. Otherwise, I'll call it 2. Okay? So now, B effect is confounded with my first block generator, right? 1, 2, 1, 2. And then let me have another block generator, BOK prim. And this time, let me say C effect. So I'll say that same things. If C effect is equal to 1, I'll call 3. Otherwise, I'll call 4. Okay? So now I have B effect and C effect become 3, 4, 3, 4. So how I generate my 4 blocks is basically using BOK equal to this guy times this guy. Okay? So my 4 blocks will be, I call it block 8, block 4, block 6, block 3. First of all, you see that now I generate 4 blocks based on the B effect and C effect. You see that? Those are four different numbers, right? But this 4 number, either you can call if this A is block 1, 4 is block 2, 6 is block 3. Basically, I have 4 different numbers, right? But what is wrong with those 4 blocks? Those 4 blocks exactly the same as my most important things I want to investigate, my B effect and C effect. So now, at the end, if I calculate this, right? So all I need to do is take the number here, okay, and I don't know which one I use for. Okay, suppose I use this one. Say this is my Y. Okay, let me just call this is my Y. Okay, and then I'm gonna sort data sort based on Y, and then no, based on block. Yeah, and then when I'm done, okay. Oh, I know why. Because I have the value there. Okay, let me copy this paste value somewhere else. Paste special value. What's wrong with this? Paste special value. Okay, and now let me sort based on my block. Okay, everybody see that I have block 1, first block, second block. Okay, do you see I have 4 blocks here? And can I calculate this 4 blocks like 4 subway stations and figure out the blocking effect of those 4? But that 4 blocking effect end up with what? The value the sum of square block will equal to the sum of square B effect plus sum of square C effect. So now your blocking effect really is stealing from the things you want to investigate. Then that will be big mistakes. And guess what will happen is that sometimes when people write this, they did not show this piece. They just show the sum of square. And people just say, oh, happy, I got everything. Until you start looking at it. How did your block confounded with your things you're interested in? Here, because we don't have too much time. I only give you 2 main effect and 1 interaction term. But in the real world situation, say that you don't need to have too many, just 4 or 5 main effect, and 3 or 4 two-way interactions. The table will look messy again. So you could easily escape from a sharp eyes. But when you realize, you made a mistake, you confounded your blocking with your main effects, well, it's too late. You guys follow me? Okay, show hands. Everybody sees that this is the wrong way to do blocking because the blocking effect will be confounded with your major sum of square, the one you want to investigate. Or you don't get it. Did you get it or you don't? Okay, so this is the wrong way to do it. And if you did it this way, you don't get extra credit. Okay, now, next, let me show you the not so perfect way, but kind of like most likely will get away with it way. Okay, how to do that? The way how I will do it is this, okay? Okay, this is actually got nothing to do with experimental design. Got more to do with, do you know how to write code? Okay, anybody know how to assign this into 4 blocks? Equals, well, people probably will say, oh, let me do this. Do a ran between, and say, oh, give me generate random number between 1 to 4. Okay, and then I'll generate 1, 2, 3, 4. Okay, now you generate 1, 2, 3, 4, 4 random number. Can you use this way to generate 4 blocks? Why not? Because it won't be balanced. You'll have some more 1, more 2, who knows, right? So this is another way to do it, to generate 4 blocks. So what will be the way? Anybody? Yeah?
So the way that I did it is I generated a random number for each of the different values, and then I ranked them.
Ha!
And then
We're on the same page.
Ascending order, and then the
Good job. That's the way I wrote it too. Everybody heard what he said? The way how you do it is this way, okay? You say 1, okay, 2, 3, 4. 1, 2, 3, 4. And then you have 1, 2, 3, 4 and said, okay, those are the number I'm going to do. And then I'm going to do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And once you do that, you know balanced. You're going to have equal number A1, A2, and A3, A4. But the problem is, if you follow this sequence, most likely this is going to be confounded with A and B. So now I'm in trouble. So how to get away with that is like Noah said, okay, let me create a random number. And then once I create a random number, okay, I store, no, I have to lock the value, otherwise I'll be in trouble again. I will paste special value. And then once I'm done, and I say, hey, sort it. Because once you do a data sort, okay, and sort it by the block, now this should be the 1, 2, 3, 4, 1, 2, 3, 4, and then you sort them and then generate your blocking effect, okay? Most likely, especially for this problem, because we only have, what, 2 main effect, 1 two-way interactions. So using this approach, most likely you're not going to be in trouble, okay? But I will say that this is not the best answer. There's an answer even better than this. So I already show you what's the wrong way. And I show you this is the kind of like, the random approach. At least you'll get some answer, good enough answer. What will be the best way to generate the blocks? You guys follow my questions? I rank them. I confounded. That's that's terrible because you ruin your experiment completely. You're gonna get caught, and then people say cheater, right? So that's not the right way. And using randomizations, how likely this randomization gonna end up was the wrong way? It is possible, right? Right? So how to get away without having that problem? Anybody? So, what is the perfect way? People will say, this is good. You're not gonna be in trouble. Where's Howard? Not in? Okay. Kevin? What do you think? What will be the way people will say, this is the good way? No problem.
I didn't get this problem test.
What?
I didn't get this problem test.
Okay, but what I'm saying is right now we're saying we're going to generate 4 blocks, right?
Yes.
Right?
Yes.
So, and we want to generate, and do you follow me saying the wrong way is confounded with things we want to investigate it?
Yes.
And you also follow this just, randomly approach. But what will be the best way to do it? Mm-hmm. Why?
Because you're going to block a high interaction period because those are terms that you don't need.
Yeah, we already said that I don't care about those things. So since I don't care about those things, use them as my blocking. Even they confounded or whatever, it's things I'm ready to trash. And then, since I'm going to trash that, hey, recycle, use it for something. It's a good way, right? So one things you can do here is say that you can even use this, the confounding, and say that, okay, if this guy equal to 1, I'll say it's 4. Otherwise, I'll say it's 7. Okay? And then I'll generate a 4747, and I'll generate another one, say if this guy, well, actually, I prefer to use something I never used before. So suppose that I have, like what Kevin said here, I can use A, B, C, D, E, or B, C, D, E, F, G, some two high interaction term, generate 2 number, and then multiply them, I will generate the 4 blocks. Because when I generate those 4 blocks, the 4 blocks are confounded with the interaction term, I don't care. Then wasted, who cares? Because what is the bottom line of this whole thing? The bottom line is I'm trying to generate a set of f-tests. Agree? I'm trying to generate a set of f-tests. And when I generate the f-test, I said I don't have enough money, I don't have enough time, so I need to do some blocking so I can piecemeal this sum of square. So I need to have my blocking effect coming out. But when I try to get my blocking effect, I have to say that, hey, stay away from the things I need. If you want to steal some sum of square, don't steal it from the top 4. Steal it from the denominator. Because if you steal from the sum of square there, my sum of square degrees of freedom will drop. I'll sacrifice 3 degrees of freedom because I have 4 blocks. But whatever I took it out of the error term, not took it out of the top 4. That is the spirit of the extension, extra credit. Okay, so everybody understand? If you want to get extra credit, it's not just show me. You calculate a sum of square like your homework 8. You should say that, well, there are so many different ways I can do it. What is the proper way? Okay? So, people sitting, everybody get it? Okay, that's the extension problem. Okay? Got it? Now, today we're going to start talking about exam 3. I'll do the exam 3 problem first, and then gradually. Exam 3 is all about response surface, okay? And,
This is all, we're doing it on SAS, right?
Yeah, but before we do SAS, I still need to show you some Excel, because what's the problem of SAS is SAS doesn't show you how to do it manually, and you don't see it. Yeah, I can show you this. The SAS code is really quick. It's only like 4 or 5 lines, and just let me show some of the old one. Okay. It's called response. Really, it's just like regression and very simple. Okay, and just generate the outputs. Okay, but I really prefer you follow me first. Okay. Step 1. Okay. There is a secret world about something. Okay. And this time, our secret world actually could be, in this case, I only have the Y performance is a function of x1 and x2. Okay, for this class. But in industry, when I work for airlines, a lot of time when we investigate stuff, our response surface usually 4 or 5 variable. So it's big. Okay, but for the class purpose, I'm gonna just do 2. Okay, and the response surface usually is this. For example, I'll say that for this response surface, and I'll give you guys I'll give you the plot. So you actually know what kind of response surface you're monkeying around with, okay? But in industry, if you actually have this, I said, hey, find me the max, you can just say, oh, max is here. Find me the mean is here. There's no need for investigation. Find me the toilet seat, where's the mean, where's the max? Here's the mean, here's the max, right? You just look at it and say, oh, where is it? At the bottom, at the top, right? But in industry, what will happen is that, say I want to figure out, oh, what is the optimum time to change my landing gear? I change my landing gear too often, it's, almost $500,000 a piece. I'm not going to waste my money all the time. But if I don't change just in time, I could end up with one overhang, and then the mechanic said that, okay, ground this airplane, I need to fix it. So there's an optimum time to do that. How to figure that out depends on what? Weather, runway pattern, traffic's payload, right? Cargo load, this is a heavy load, light load, and there are all kinds of things will dictate your schedule. Well, of course, how pilots' behavior. If the pilot tend to fly in a rush way, and young pilot tend to have heavy landing, then your gear need to change over time. So basically you have a regression here, okay? And then let me show you another regression. This one is, say I want to find the minimum. So the minimum is a ridge underneath, but it's kind of, you can tell it's wiggling at the bottom, and where is the minimum point? Could be somewhere in between. Okay, let me start from something very simple. Okay, and let me just start this problem. Step 1. What are you going to do? According to our experimental design, I need to find 4 corners, right? So let me just say that, oh, this is my 4 corners. Okay? And my 4 corners will be 6.8. This is my 4 corners. Okay? So you will have x1, it doesn't matter, x2 and y value. Okay? And can I copy the 4 corners first? So I can do the 4 corners. Okay, I will write a 4 corners twice. First time is I will have -1. Let me lock the value for a second. I have some random number in there, so this thing is not locked. Control C. Paste special value. Okay, so my first 4 corners is, let's just call this as x1. So x1, -1, -1, and positive 1, positive 1. And of course, this is negative 1, positive 1, negative 1, positive 1. And then what are the four values? 14.53 and 6.7 and positive 1 is 15.8. 15.8 and 7.64. Everybody see my first four value, where I get those four value from? You see it? So I'm doing a square dance, right? This is my first four corner. And according to Montgomery, I have to have the center value 0, 0 several times. So I'll have a 0, 0, 0. Well, let's just say I did it 3 times. Okay? And the center value should be somewhere around this 11.28. And this 11.28, if I measure 3 times or 5 times, not going to be exact, right? Will be a little more or a little less. So let's just say that it's 11.28, 11.27, 11.22. Okay. This is your first experimental design data. Use this data. What are you trying to do? Are you guys Google anything important, or are you going to tell me the answer? Anything? I have this. Anybody agree with me? There are 7 numbers, right? What are you going to use this 7 number for? Let's say we'll try to find a max. Okay? Yeah?
Going back just a tiny bit, why are there 7, not 8?
What do you mean?
Or like, why are there 7 numbers?
Oh, I have 4 corners, right?
Right.
And then the center, remember we have this square dance, positive 1, negative 1, positive 1, negative 1. But then the center points, because I try to, well, actually your question carries certain meaning about what I'm asking, or the answer I'm looking for. Here, so everybody agree with me? We're at this we're around here, right? At this spot. So what you're really trying to figure out is that, hey, should I go this way? 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 Which way should I go in order to make my to grow more? Agree? So actually, what I can do is what? I can do calculate the differences, or just say that, oh, you're looking for max. I can go 15, I can go 14, I can go 6.7, I can go 7.4. Which corner should I go? Just go to 15, right? That's my champion directions. So I should go here. So I should move here. And then once I move here, I will build, too quick. That's 15 is my new center, and then I will build a new square. And then 4 corner, what are my 4 corner? 18, 19, 11, and so I will copy this. Okay, so my center should be around 15.83, right? And then I'll have a new negative 1, positive 1, positive 1 to build my 7 value. Okay? Do you agree with me on what I said so far?
So it's 7 because it's the 5 you originally do and like the 2.
Well, yeah. So here's the part. If you have a lot of money to run a response surface, you will have more center points. But if you don't have too much money, I probably will have 2 or 3. And why I need 2 or 3 center value is because I need to figure out, hey, how much uncertainty in my 0, 0. If I have a lot of uncertainty, then when I said that, remember, do you really care about this certainty, or you just want to use this certainty to say how trustworthy to go here? We said that we can go from 11 to 15. The improvement is what? About 4, right? Right? But if here, the center point, the variation is 11, 18, 24, with a lot of oscillations, do you trust that 15 directions much? So in other words, you probably will say that my square, okay, may be too small. I need to have a little bigger steps in order to see the differences. So what I'm saying is, hey, people, right now I'm only making the squares this big, right? Right? Can I make this things 5 by 5? Young lady, can I make the square 5 by 5 and said, here's my center, and here are my 4 corners. So my 0, 1, 0, 1 is really, really big. Can I? And can I say that I don't want 7, I don't want 5, can I make 7 even bigger? Or, on the other hand, can I make it really, really tiny? So right now people see, I'm just faking it, right? See the jump is 5.6 to 6.2 to 6. Every 0.6, 1 step, right? Can I make this really, really tight? Okay? So you asked me a question, let me ask you the question back. Why I need to have center point? The center point show how much uncertainty I have in the middle, and I use that to decide how big my cage or my square is going to be. Because if I know that this thing is very, very uncertain, okay? If I said that, when I'm wiggling around, the answer I'm going to get is +2 minus 2. Then you tell me that I'm going to investigate something, could vary around 1. I don't care. Hey, make the square a little bigger. So now, at least, when my local variation is 2, but your jump, increase or decrease, is 4, then I know that when you say go that way, you can improve by 4. The gamble makes sense. You follow me? Everybody follow? So variations, okay? This variation, square dense. So when we talk about response surface, we're really talking about deja vu all over again. Start from day 1 of our experiment. Local commute in, the subway station. So I'm kind of like, hey, build my subway station in this corner. Build my subway station in the next 4 corners, in another 4 corners. So we're just doing the subway station things again and again and again. So when you do this, you basically, here's the intelligence part, okay? If you don't care, you plug into SAS, how quick SAS will give you a set of answer? 2 seconds. But garbage in, garbage out. The real intelligence here is not just plug in the number. The intelligence here is that I give you a response surface to investigate. I even let you know how it looks. Okay? Here, for example, you guys know that U.S. construction architecture law for our stairway. Okay, usually the rule is 7-11. The run and right, run is every 11 inches, and the height is about 7 inches. So they call it 7-11 rule. Why they come up with that rule? Because if say I have every steps, okay, the increment is by 20. Do you think that's good? Because there will be a lot of senior citizens that cannot climb, or the drop will be too dangerous, out of balance. But if I make these things extremely long, like, every increment is 2 inches, but every run is like 24 inches, can I have a very, very shallow stair like that? 20 inches, increase a little bit. 20 inches, increase a little bit. What will be the problem? Then you need a very, very large space to build that stairway, right? So you guys visualize this? So we're doing the same things here. Or basically said that, hey, I want you to investigate how to get here. Okay? And in the real world situation, you don't even have this plot. You just, have some data, some gut feeling. But the game you're going to play is always the same. Find me 4 corner, and then the 4 corner, they will have this is experimental design called X1, X2, and there will be a true name, true value, say epsilon E1, I'll say come up with a name, LAN 1, LAN 2. Okay, and the LAN 1, LAN 2, the value should be what? Originally, see here, -1 is 6.8. So you will have 6.8, 6.8. And then 1 is 8. Is it? No, 1 is 8. A. And then the center is 7.4. 7.4. And then, of course, on this side, you will have, what's the value? 65775. Okay. 6575. 657.5, and then 777. Okay, so what you're gonna put in SAS every time is just every iteration is those value. Questions? No questions. That's the SAS input you need to use. So when I said that, when you ask me, hey, are we going to use SAS? Yeah, but your problem is not from SAS. Problem is from whatever the table I give you. And every time you're looking for what? You're looking for the true name of the variable, the square dance, and then the observation value. And since I put random number in there, they will generate the number for you. Okay? And of course, so far, I'm cheated here. I'm trying to help you visualize this. So I said it's a square dance. Because in reality, do you think the square dance will be sometimes cut a corner? You follow me? Here, in this problem, okay, what will be the best way to grow? This way, or 45 degree, or probably, say, 75 degree, right? So you need to find a direction to grow and say that, oh, well, if I'm following the square dance, is what? Go this way, goes that way, that way, or go 45 degree, 45 degree, 45, negative 45 degree, right? That's my four corner. But in reality, if I investigate this response surface enough, I should say that, no, it's not 45 degrees, it's 75 degrees, it's 62 degrees. There is a true orientation I should use. That's something we need to calculate. Or SAS should calculate for you. And I'll at least do one or two manual so you understand how it works. But everybody agree with me now, experimental design, regression, and optimization, all in one concept. Agree? I square dance. I use my square dance with some center variation to figure out how to dance. How far should I go? And then I also use that to figure out what is the best direction to find a max value or find a mean value. Okay? And one more, okay? In this class, or SAS, they use max, okay? And always the default problem is max problem. So if you have a minimum problem, rather than going up, you're trying to come down. Anybody know how to do that? How to turn a min problem to a max problem? Flip it upside down. So min problem become max problem. Okay? Or you can do this. Just the whole thing's using, say, 10 million minus the y value. So the entire y will flip upside down. Convex become concave, and then you can do it. Okay? Okay, before I go any further, let's think about this whole thing one more time. The problem you're going to have is I'll give you a wiki function so you know what kind of surface you're looking for. Okay? I also will tell you you're looking for max or you're looking for mean. Next, I will say that that's part of the exam. You find a starting point. And how you decide your starting point, I will give you more detail. Okay? But say you find a starting point. Okay? How many of you ever watch people climb Everest, Himalaya? Never? Do you guys think that when they, of course, you have to physically fit and everything. Do they always try to get to the top in one shot? Or they will have some safe checking point? They call it base station, station 1, station 2, to investigate. Why they do that? Because there will be certain points, they call it points of no return. If you gamble, go up, you better make it. Otherwise, disaster will happen. So you have a center point, and then you decide where you start for investigation. And I probably will say, okay, we'll start. I'll give you one or two starting points. But then I'll say that the starting point I give you sucks. Not going to help you get to the answer quick. Can you tell me what will be an intelligent way to do it? And of course, you cannot say that, oh, you're looking for mean, so I'll start from the mean. You're looking for max, I'll start from the max. Then there's no investigation needed, right? But let's just say that you find a starting point. Okay, step 2, what need to do after I give the starting point? I'm going to start there for a 2x2 two variable example. What will be your next things? Huh? Aha, good. So we need to find the cage. And you can make the cage very big. You can make the cage very small. And how you decide how big is big enough, how small is small enough, right? I'm at a 0, 0 to positive 1 to negative 1. I need to make sure that the 1 is the improvement or drop is bigger than my center variation. If my center variation is tiny, right? And well, think about your exam 2 problem. I give you a bunch of random number, right? As your local commute. And so when you build your B effect, C effect, what was my questions? Is it big enough? Because if it's too small, your local commute bigger than your subway station's distance, then who cares about subway station? I'm just, I'll just use the local commute, right? So same things here. That question is same thing as your local commute versus your subway station. You want to make sure, okay? Say I find my 4 corner is this 4 corner, okay? If I say my 4 corner is this 4 corner, okay? So the jump or differences, look here, is from 4.8 to 18. And so the difference is about 14, right? Right? And if the difference is, largest difference is 14, but when I check the randomness, say 3 repeated observation from the center, the local variation oscillation, okay, is 20. If the center variation is 20, would you go with that cage size?
No.
So what do you do?
Make it smaller.
Huh?
Make it bigger.
Yeah, you make it bigger because then you have enough improvement. But on the other hand, okay, I look at this and I realize that, man, the cage I built, okay, the detectable differences is, say, 10, 20 times more than my local oscillations. That means what? My step size may be too big. And this is the experimental design way to talk about things. Let me use another way to explain this. This is Dr. Qiaozu Lim's way, okay? But Dr. Lim probably will say, because he's a true optimization guy, okay? So in Dr. Lim's world, he will talk about global and local optimum. And let me show you an image, okay? So here is the global local optimum picture here, okay? So we're looking for a minimum. Here is a minimum, right? Why this is a minimum? Because if I do my square dance, no matter I dance to the left, dance to the right, this is a sweet spot, locally, agree? Here is another local sweet spot. Here's another local sweet spot. But the true optimum is here. So let me ask you these questions. If my cage is too small, what will be the concern? If my cage is too small, my square dance is too small, what will be the concern?
You wouldn't find a global optimum
Because you got trapped
in the local.
in a local world. So now, it's, I want you to think about this, because this time I'm going to give you the exam 3. Probably, I told you, very early. So I'm not going to say that, give you 4 hours to do it. I'll give you enough time to play with it, because there's no perfect answer, but there are perfect logic. What is the perfect logic here? You cannot just say that, hey, I look at a picture, you want optimum, I find a minimum. You want a maximum, I give you the maximum. I need you to say that, what if this is a real world? You don't really know the landscape. How can you use enough information to figure out that where's the optimum, where's the minimum? Also, you need to say that, am I building this investigation too conservative? Okay? Say, the door is the max. I need to go to the door. But my step size is like, 1 inch at a time. When am I going to reach there? Long time. Okay? That's bad, right? But on the other hand, if I have a step size, okay, say is this big, okay? My step size is about this big, okay? From here to here. What will be the possible disaster when you do it that way? So you have first step. Let's say first step, you're reaching a optimum. And then you have another step, you're reaching another optimum. And then you have another step, you overpass that global optimum. That means what? Your investigation is way too rough. The grid is not small enough. And that's why I said, problem like this, it's not just doing experimental design. You start thinking about chain of experimental design, or that's why we call it response surface investigation. You follow me now? Okay. So the questions is, okay, step 1, find a center point. Do a repetition sampling of the center points, so you can have some people take notes. Okay, so don't come back and say that you didn't say that. I want you to think through the steps. First, you have a center point. And then you repeat the measurement, that center point, depends on your budget, 3 points, 5 points, you will know your variations. And then once you have enough, you know your variation or your center point, you need to decide your cage size or your square dance size. Because you want your square dance far enough to see the improvement, but sensitive enough to overcome the local variations. So far, so good? So that is from statistical point of view. And then after you have this statistical point of view, you know that basically you will have a square dance. So let me insert a shape. Where's the shape? Okay, so let's say that I have a square dance. I'm going to do this square dance 1, square dance 2, square dance, let me maybe do it for real. Okay, and say I will form a shape. Where is the form a shape? Okay, and I'll fill, and I'll make it 80. Okay, so, and then let me have my line in red. Okay, I have my first cage, and then I use my first cage to decide where's my second cage. Okay, and then, so my second cage is going this way. And then my third cage is going, is going this way. And my fourth point is going this way. Okay? So you need enough square dance to help you gradually move to the minimum and maximum. That is your exam 3 for different response surface. Okay? And how to figure out the directions and how to figure out a detailed computation, I will show you the SAS code. But can you visualize the problem now? Okay? How many of you think that piece of cake?
You would say that.
The devil is in the detail. Okay? And after that, I probably will, have time out, come back and talk about some of the fuzzy logic, some of the more data mining, machine learning's arguments about response surface or trust regions computation. But the key is we need to do a chain of experiment. So that's why I said no more Excel. Let's just go to SAS. There's too much mechanics we need to deal with. But you need to visualize why we're doing this. Okay? And of course, everybody will have the different random number, different plot, and you have to decide what is your right size. Okay? And let me ask you another question. Okay? Do you think that for pharmaceutical company doing the BNT, different chemical compound for the next? I look at my COVID card. I already have my third shot, right? My booster shot. But I look at the column, the row. There still have 2 left on the first page. In the back, there are 3 more. So guess what? What's my gut feeling?
More shots.
There are more shots. Okay. So they probably gonna like flu shots. They keep investigating how this virus gonna mutate, and alpha strain, gamma strain, who cares? But they need to come up with something to minimize the casualty, right? So when they do this, do they really have a direct line with the virus? The virus gonna tell the pharmaceutical company how they're gonna mutate. So they need to figure out where is the most likely location for the development. And when you run this, okay, say, just look at this response surface, okay? Do you think that we try to find the 2 corner for max and the center for min? Do you think that's the only things pharmaceutical company care about? What else do you think pharmaceutical company care about? Or, this could be a critical flaw investigation. What kind of things will make the most damage? The guy in red t-shirt? You? Huh? Reaction time? Well, how long it takes to investigate, that's part of our step size, right? Large step, you overshoot. Small step takes forever. No, not reaction time. I'll give you the honest investigation as a scientist. I'm also going to tell you what industry also use as a dirty tricks. Okay, when they talk about this, what do they really have in mind? Money. Of course, it's all about money. What they really have in mind is this. Okay, a lot of time they need to figure out some local trap. So they're interested in the global optimum, but they don't. So put it this way, okay? Like your iPhone. A lot of time they actually figure out iPhone 20 or certain design. But why they don't want to push out the design in one shot, give you the best in the first 3 years?
Nothing else to sell.
Yeah, they want to maintain that's why I talk about my vaccine shot, is that they want to say that, okay, I give you something you will buy. And then what will happen next is wait till a certain time, hey, would you like to have another one? Then I can keep coming back. So I need to figure out where are those local stable point. And of course, a lot of time the competitions will also try to do the same things. So everybody trying to do what? Mine is better, but not way better than yours. But my answer is just better enough. I can dominate the market for the next year. And once I can dominate the market in the next year, I'm start thinking about where's my next local optimum. So I will come up with another solution, not very, very good. Actually, sometimes I even know where's the perfect answer. But it's just good enough to dominate the market again. So when you investigate a response surface, sometimes the argument is not just to find where's the global optimum. You also try to figure out where the general landscape, to figure out how to play with it. So for your exam 3, initial problem will be pretty much the same. Find a starting point, find a cage size, and find a mean and find a max. And then after that, I'll say that, hey, here's the budget I'm going to give you. You can do this for 200 trials. What will be there's no perfect answer for this, okay? Extra credit. How you can use this 200 trials in such a smart way, you figure out how to sample the whole world just enough so you can figure out, hey, I can have a stop here, I can play something here, so I have the best freedom to manipulate the virus or the iPhone market. You guys follow me? So that will be, much, much higher level of intelligence to talk about. But before we get into the high level one, the one that I need you guys to think about is how to manipulate the simple one, okay? After I upload the tape today, I probably will start thinking about how many problems I'm going to give you. I'll give you the problem first, and then I'll run through the SAS steps, make sure that everybody have the same backpack to, same snow boots to trail the landscape. And then, and I probably will give you guys a little bit of leeway. Say, okay, you can investigate this because usually I create a problem in a symmetric way. So some start from the left, some start from the right. That way, you cannot just copy paste your friend's answer. Okay? Got it? I know it's a lot of labor intensive part, but if you do it right, actually this is fun. Okay? Am I done for the day?
You got 5 minutes left.
Okay. The T8 for the since I give them the extra credit part, so if they turn in the extra credit part, also grade the extra credit part. Okay.